Hi, okay, so Assalamualaikum, a very good evening to everyone. So today we are going to present our project on machine learning and neural network. The title is Prediction of Heart Attack. Next. So for today's presentation contents, we will start with the team profile, and next is introduction, algorithm choose, preprocessing to modeling, and we will end with the solution development. Next. Okay. So let's Farah, Iman, want to start with your.
Hello everyone. My name is Iman Nabila. My metric number is 204190. So I'll pass to Farah.
Hi, my name is Farah Adlina and my metric number is 20217.
Hello, my name is Amirul Najib Mohd Solong and my metric number is 207145.
Hi, my name is Nurul Adila Binti Zainal. My metric number 202713.
Hi, my name is Najiah Binti Risdan and my metric number is 200254. The next. So we will start with the introduction. So what is heart attack? So basically, a heart attack is also known as a myocardial infarction. It's a serious medical condition that occurs when the blood flow to the part of the heart is blocked, and this blockage can occur due to the buildup of the plaque in the coronary arteries. So which are the blood vessels that supply oxygen and nutrients to the heart. And without enough blood flow, the heart muscle can damage or die. So according to the Department of Statistics Malaysia, estimate heart disease ranked second with a 13.7% after COVID-19 infection as a cause of death in Malaysia in 2022. Meanwhile, in 2020, it is the leading principal cause of death, which is with the 17% of the 109 and 155 medically certified deaths. Next. So our problem that we have identified is hospital basically have a large number of patients, right? So it can be difficult for the doctors to predict a patient risk of heart attack because there are so many factors that can contribute to the development of the heart disease. There will be a time where the doctor overlook their patient. Thus, they need an assistant to help them predict the risk of at their fingertips. So the objective of our project is to make the system that enable to identify individuals who are at the risk of experiencing a heart attack and a low-risk patient. So with it, doctor able to help in early diagnosis and treatment of the individual who are at the high risk of heart attack, which can reduce the mortality rate and improve overall heart outcomes. As for the low-risk patient, doctors can help them to maintain their health. So thus we can decrease the death rate due to the heart attack in Asia. Next.
Okay, now we will proceed to algorithm. So we have choose two algorithm to predict to make a prediction for heart attack, which is decision tree and also the random forest. So next. Okay, first we go to the decision tree. In decision tree, we begin at the tree root to anticipate a record class label. We contrast the root attribute value with the record attribute, and we follow the branch that correspond to the value and go on to the next node based on the comparison. Up until we reach the leaf of a node with predicted class value, we keep comparing the attribute value for our record with other internal nodes in the tree. As we are aware, the target class or value can be predicted using the decision tree model. Next. So below are the sum of assumptions that we can make while using the decision tree. which is first, at the beginning, the whole training set is considered as a root. Second, feature value are preferred to be categorical. If the value are continuous, then they are discretized prior to building the model. Then record are distributed recursively on the basis of attribute level in order to placing attributes as root or internal node of the tree is done by using some statistical approach. Next, we see a random forest. So random forest is an ensemble learning method for classification, regression, and other tasks that operate by constructing a multitude of at training time. So there are several steps that will describe the random forest algorithm execution. So first is a few new data set, which is training data, will be built from the training data set. Second, the row in the new data set have the same number and it randomly choose from the original data set. Third is there is possible for the one row to appear more than once because we are performing random sampling with replacement. That means after selecting a row, we put it back into the data. So what is process of creating new data set is called bootstrapping. Next. Then independently we can train the bootstrap dataset to decision tree. It is to predict using this forest. It will pass a new data point to each tree one by one. So now we will combine all the prediction from decision tree and take the majority voting. So this process of combining result from multiple model is called aggregating. So the majority voting will be the result of the prediction. This combination, bootstrap and also the aggregating is called bagging. Next, pass to Farah.
And now I will present on the pre-processing to modeling. Next, Najib. For the pre-processing and modeling, we first start by importing the libraries before uploading the files to Google Colab. Next, we do the first phase of pre-processing, which is first we check for missing data to remove noise. But this data set do not have missing data, so we can go to the next step, which is checking the data type. We found that all headers are in numerical type. Then we move to feature selection. We use mutual information, or also known as information gain, in decision tree. After this is the second phase of pre-processing. We can select the predictors and set the target. We also split into 80-20 and 60-40 ratio. Lastly, we visualize the target to confirm if the dataset is imbalanced. Apparently, the dataset target is not much different between the two values. Hence, there is no need for this oversampling. Then we apply the classification model, which is decision tree classifier and random forest classifier. So next, Iman will present the result.
Okay, thank you, Farah. So I will show the result and the most suitable algorithm we have used for the product. Next. Next. Okay. Okay. For the result, as you can see here, in the table, there are these are the result for decision tree and also random forest. So as you can see, the highest accuracy that we have reached is for the random forest, which is for 60-40 ratio. And therefore the suitable algorithm that we are using is random forest for the model for the data product, because the random forest can draw inferences about the target items, value or input parameters from observation about the item. Therefore, depending on the state of the variable, it can examine two different options. And if the target variable is continuous, the issue can be resolved in a regression context. If not, it can be solved as classification. So in conclusion, because random forest use assemble learning, which includes the prediction from various decision tree to increase the model overall accuracy as well as achieve a good performance in this experiments, it is a suitable algorithm for our heart attack prediction system. So yes, the next one, I will pass our data product to Najib.
All right, okay. Thank you, Iman. So we'll move on to the solution development. So yeah, before this, my group mates have presented on our data, on our objective, and the actual algorithms that we use in order to achieve our objectives, right? Okay. So we have what we essentially call the brain of our system. So for our solution development, as mentioned before, we use Google Colab primarily for our classifications and our data processing. And then we use Jupyter for the actual app development building. Of course, all of this is using Python language, programming language. So yes, our system structure is a very simple one. So basically, we will input our patient data into our system. And then with the data, it will use the model that we concluded, which is the random forest 60-40 ratio. By using that model, we then predict based on the data whether or not the patient is either having a high chance of a heart attack or a lower chance of a heart attack. And then we display results. So that is very simple. The system structure is used only by medical professionals like doctor, because the data set we use and the feature selection slash the conditions of the patients that we collect are very medical term heavy. So for general use, is not suitable. So it's only for doctors as they understand more in the medical perspective. So how do we develop the app is first is to initiate our Jupyter tool. So we have the Google Colab system, the brain already, where we identified the random forest model 60-40 is suitable. So we then insert it into our Jupyter tool. So we initiate a Python programming environment using Jupyter. Next, we imported the libraries, of course, to code it by scratch from everything without using the help of libraries. It would be very difficult and the code would be super long. So we import libraries such as libraries that are capable for data management, calculations, classification, interface, and porting. More on those later. And then with that, it moves on to dataset management. Basically, we found the dataset from Kaggle that is suitable for our problem, and then we ensure that it is actually readable to the system, and we split the dataset as mentioned before by my colleagues. So the last 4 steps are is the model implementation. So since we already have the model, we just insert the model into our application environment, our Jupyter environment. So the model is using scikit-learn libraries to help in classifying using the random forest classifier. Yes. And then we pickle it. Pickling is basically a conversion of Python objects to byte streams with pickle library, so that it can read the data set and display the result better. And then next, of course, the actual application part, where we develop the interface, so create an interface to collect data and by using the Streamlit library. And then last but not least, since the actual application itself is in our device, Jupyter is a local device programming IDE, but it ports it, or it uses a web environment to propagate, to display. So in order to propagate the actual app, we have to use an ngrok library to propagate it in our port 8501. So this I've explained about our app development. Let's have a look at the model of our app. So first things first is that we initiate our Jupyter library. So not this one, sorry. So this is our in order to initiate our Jupyter library, we have to first go through our own devices command prompt, my Python file. So once we run open this. So this this interface here reflects back to the file that we opened just now, which is the Python file. So everything that is in here should be the same as what is our Python file. So yeah. And so for the application itself, it's in the app.file. So this is the full code for our. So yeah, I don't think I will explain it here. So once we have the code, once we develop the interface and application, we then run the actual application using the Streamlit library. So Streamlit library is basically a library that helps in developing a interface, a web interface using Python rather than directly needing to program it in PHP or whatever. So yeah, Streamlit library. So we just run this command streamlit run the actual file that we want to run. So and then it will port it in our local host 8501 since we set it port 8501. So yeah, this is our application. Very simple since it's used by only medical professionals. So as mentioned, this is a heart attack prediction. It's not a definite diagnosis heart attack. So the machine itself is accurate, but it shouldn't be the definite diagnosis for doctors to determine a patient's condition. But they can just take precautions based on the probability. So yeah, let's try and run it. So this is the default settings. Everything will be set like this. So let's say I'm a doctor and my patient is having some pain in his heart, or maybe I want to check my own probability of a heart attack. So I'm age 22. So I'm a male. I don't have chest pain. My blood pressure is in the range of normal. Cholesterol, I am around, I believe this, and then blood sugar level should be a bit low on 90s for average. And then electrocardiogram normal. See, as you can see, this is electrocardiogram results, blood sugar. All of this must be done with using tests at hospital to then insert the data here for the doctors to know whether or not they have a probability of a heart attack. So electrocardiogram result is normal, heart rate achieved highest would be around 118, sure. Induced angina, no. ST depression. So ST depression is basically an abnormality in the ECG or the beeping of the heartbeat when you see the screen. So and then slope peak, upsloping flat, major blood vessels severe, 2 fixed defect, normal. So let's predict. So it will take a bit some time for our system to display the results because it's running from my device, our device, and then porting it into the web. So yeah, let's wait a bit. So while we wait for the result, so as mentioned before, these are very medical savvy or medical heavy terminology. Typical angina, atypical angina. What is angina? You don't know, right? I also don't remember. We have blood pressure, we have cholesterol. I think that one is quite normal already. If you don't know, then you should know lah because it's your health, man. Okay. Blood sugar, electrocardiogram result, LVH, left ventricular something. Yes, I forgot. But okay. Exercise induced angina. This is taking too long. I'm trying to buy some time. Okay. ST depression, slope of peak, exercise ST segment, number of major blood vessels colored by fluoroscopy. Colored by fluoroscopy. How they put fluoroscopy in your heart, I don't know. It's okay. Since it's taking some time, let me show you what we put in our Google site solution development. Yeah, okay. So once the app is displaying result, it will show something like this. Based on patient's condition, chances of a heart attack is predicted to be in a low chance of heart attack state. So yeah, this is not based on this one. Basically, it will display this. And if, let's say, the chances of the heart attack is higher, same display, same results, but it will say it will display to be in high chance of a heart attack state. So let's see if it's still running. It's okay. But what it will show is just like this stuff. Bottom below here. Okay. Drum roll. Okay, still running. You're making this awkward. Come on, computer. Okay. So yeah, that's basically it for the application development, the interface for our system. It's very simple. It's because this project is meant for identifying which algorithms is better. So this is a little addition to our project. So since this thing is not being cooperative, we will skip it. But it is running. You can try and load it yourself later, but the display results will be like this now, so should be no problem. Yes, it's my laptop's problem. I have a lot of tabs open. So I think that's it for our presentation for this project. Hopefully everything is clear, and that's all from us. So thank you.